So the third part is about project management. That is about systematically avoid conflict in advance. And what we use here as an example how you can do that is SCRUM. SCRUM is a project management method that is used in software development, but we think that it has really good elements that can be used for any types of projects where something is being built or developed. And at the end, I would like to talk about resource management. I need to go online for this because unfortunately this is nothing that you can download. Video I think shows what SCRUM is all about. Self-organizing teams. It's a different type of working together. It's all mixed up. I hope it gave a good overview. I think we are pretty late already, so I won't talk about more details about SCRUM. If you want to get some more details, I've got a few copies here from the SCRUM reference card that basically sums up what we just saw in the video.
But so you work in software development, don't you? So do you use SCRUM at your work?
Yeah, they do use SCRUM actually.
Yeah.
But yeah, we think that with some adaptations, it can also be used in non-software projects. And SCRUM itself comes from manufacturing with some, like from a, what was it, a Japanese manufacturer. And it was, it's called Lean, the process is called Lean that the manufacturer uses. And then SCRUM was built on, like, for software projects. And
when it was being explained, like how all the processes in the blender and you have like small little cycles, it reminds me of almost like mobile phones. You know how they keep releasing like you know, iPhones like 1, 2, 3, 4, 5, and then they keep getting a little bit better each time. And they look the same and they functions pretty much the same.
Yeah, that's a good example.
Yeah.
For different projects, we might need different sprint lengths. We might need a few modifications. One thing is that producers could also be the consumers. So think, for example, of a community that does something together. Then everything that is done in the community, everyone benefits from. So there might then be some overlappings. One thing that we heard is that the roles are defined very well, but I think there is still some possibility to have a common product ownership, which means to commonly define the priorities. I guess it needs to be tested. I don't know something where it's practically used. And if it comes to bigger projects, something more like maybe a building or even a city or something like that, it needs meta teams and team hierarchies. Meta teams would be teams that organize teams, for example. Then the last point, resource management. There are some things, some ideas from SCRUM that can be used. So we have the SCRUM backlogs that define which tasks have to be done. And then there are can be SCRUM teams that estimate required resources. Not just time that is required, but also let's say it's actually physically built things. Then they will define how much resources they need to build a certain thing. The product owner or product owners would choose a team then based on how they say they want to realize the project, and then it's possible to calculate cost per priority point. That might sound a bit weird. I'll just show it in a second on an example how that could work to maximize realized priority points. So what does it mean? We've got here a simple example just with money. I will show in another example that it can work with any type of resource, but for simplicity I show first how it can work with money. And we've got 4 projects, and however the priority points have come up exactly, might be an expert team that came up with it. It might be some kind of voting. however they came up with it, the 4 projects got a certain amount of priority points. And we get an estimation of how much those projects would be to realize. All the numbers that are in this table are purely fictional. They are fantasy numbers, so just to see how it could work. Doesn't mean that the cybernetic farm system would cost $3 million. It's just a number. This last column here shows Australian dollars per priority point. So it means we divided the $3 million by 798. What does it mean? It means that one priority point costs $3,760 for this particular project. So the cheaper this is, the more priority points can be realized with per dollar. So we can sort the projects by this number, and we see that like most value can be created per dollar with building a cybernetic farm system. The next one would be the high-speed railway, the next one the bridge, and the high-tech eco village is the most expensive per priority point.
So are they saying that we would still get a say in the facilities that were provided for us?
Oh, cool.
And in this example,
yeah, I just wanted to make sure.
yeah, and in this example we see that we just say that $750 million are available, and then you go from the top to the bottom of the list and sum up the values, sum up the cost, and then you see which projects you can actually realize. And it turns out that you won't go from the cheapest to the most expensive one. You won't even go from the one that has most priority points to least priority points, but it's ordered by this, and then you see, okay, this one for $120 million, that's what you cannot build. The other ones you can build. And here is a more complex example. It works the same way, but here we do not just have Australian dollars. We have actual steel, concrete, wood. Again, just fictional numbers, so it doesn't mean that these projects actually need this amount of resources. It's just to show an example how it could work. And what you do with this is you do the calculations, resource per priority point for every single resource. And if we look just at steel, then we will find that the cybernetic farm system is the cheapest per priority point, then high-speed railway, the high-tech eco village, and the bridge. So this is the ordering, and we have 200,000 kilograms of steel altogether, and then we sum up again 5,000, because that's the cheapest per priority point, plus 150,000, that's the next one, plus 20,000, and now with the 80,000 we would go over it. So these 3 projects could be built with the amount of steel that we have available. And you do this with every single resource. Concrete shows a different one that can't be built, because it depends on the amount of resources that you actually need. So every resource is divided by the priority points, but this one needs 80,000 kilograms of steel and only 20,000 kilograms of steel for this project, but here we have 60,000, 30,000, so the values here will change, and you get a different order. There can be resources that are abundant enough to build all projects. And here there are a few more resources for the same projects, just to show. This one, for example, shows that there might be, it's just a number, a fictional number again, 400 tools are needed for those 3 projects, but the tools per priority point determines, because this is the cheapest per priority point, that this is the one that should be built with the tools that are available. So what this table shows is you've got some red numbers for the bridge and the eco village, so they can't be built. But all the two others can be built because they have all green numbers. There are still some open questions with this resource management method. What to do with the remaining resources, for example, because there are still some resources available when you just sum up all the numbers. There are different ways, different things that you could do. You could simply say, okay, you won't use them and just keep them for later use. Another way is to sort the tasks purely per priority points and then go through for which projects do you have enough resources and do those. Or you can sum up all the ranks. We ranked the projects for each resource, and if we sum up all the ranks, then we might get an order which we go through top to bottom and see which projects we can still build. So there are different things that we can do. Also, dependencies might need to be considered. So, for example, windows cannot be built in a building if there are no walls. So if one project is fixing windows and the other project is building walls, then you can't fix the windows without the walls. So dependencies like this need to be considered too. And also there might be incorrect estimations, which changes the actual resources that I use. So it's just like just some thoughts in which direction it can go. Sorry?
I mean, each project would need to be fine-tuned anyway.
Yeah.
Depending on.
Yeah. So it's an idea that for resource management that can be used in any community or organization for any type of project, and it can be like the allocation of resources can be calculated by computers, and again with the decision making process that we had earlier that could be supported by AI. The priorities could also be defined by an AI in long term. If you define a reward function again, like rewards and penalties, to show the artificial intelligence what makes, for example, if it is a community, what makes the community happy, then the AI could assign the resources and calculate priorities. Okay, one last note, just a general thing that we've found that goes through all the different aspects of conflict resolution is transparency. If you hide something, then there is always a big risk of getting a conflict. So we think transparency is just an important part of efficient cooperation. What is transparency? Everyone has access to all information they need. That can be something that the information that they actually need to fulfill a task, but it can also be information that they just need for motivation. Information is easy to find and understand. If the information is available, that doesn't necessarily make things transparent. You need to find it. But transparency does not mean that everyone must know everything. Everyone should have access to the information they need, but no one should, it's not efficient or it does not help anyone if people are forced to learn everything, but they should have access to all information.
So just to recap and to finish off, the reason that we put this together and why our aim is to provide high-tech sustainable facilities for all. That's what we think that that's the direction we need to go if we want to provide everything for all of the people, not just a select few. And the RB is once again, the only viable solution that we've heard for long-term global sustainability. So we think this is really important if you really want your children to have a good future as well. So just at the end, we are providing a Future Leaders training course in June, and this will teach you how to manage your projects efficiently and cooperatively if you do have a project or if you're thinking of starting a project. It will also connect you to other like-minded people who are working on similar kind of projects. You can join the Sharewhale Future Leaders Hub, and we encourage you to continue to research everything that we've taught you today, or whatever, particularly what you're interested in, and consider obtaining your Future Leader certification level 1 if you're interested. What's coming up next? In 2 weeks' time, on the 8th, Thursday this time, so some people are busy on Wednesdays, we have another free workshop here called Open Sources for Everyone. We also have monthly Movies That Matter on the weekend with the Zeitgeist Movement, so that will be on the Saturday at 1:30 p.m. And that one's a really good one to come to if you're really interested in learning about the beginning of resource-based economy and the Zeitgeist Movement, because we're not actually showing movies so much this month. We're actually going to show 20-minute segments of what people have showcased on Z-Day. So it would just be like 5 20-minute things, and like there's probably a bunch of about 20 of us who get together and have pretty healthy discussions about all of the different things that are going on globally. Also, we have the Future of Food Convention coming up, which we've organised in conjunction with Alf from Organic Farm Share. He owns a farm on the border of Queensland and New South Wales and provides local organic food to the Brisbane region in northern New South Wales. And also we'll have Douglas Malat from Cybernative Farm Systems Skyping in from America. And he's got a really cool project where he's working on automated foods production locally grown using aquaponics and things like that. And also we have our Future Leaders workshop, as mentioned before, coming up in June. And if you want to learn more, you can register at Sharewhale, you can email us,